The current cosmological model holds that the observable universe is a spherical spacetime centered on Earth with a radius of 46.5 billion light-years, which contains at least 2 trillion galaxies. The Milky Way is located within the local group. The local group in turn lies within the local cluster, and the local cluster is part of the Virgo supercluster. As for the Virgo supercluster, it is nested within the larger-scale Laniakea supercluster. In this super-celestial system that resembles a feather in appearance, the Milky Way is merely an insignificant grain of sand. But is Laniakea the largest cosmic structure? The answer is negative. Over the past 10 years, the astronomical research team at the University of Hawaii has been mapping the distribution of galaxies near the Milky Way. The Laniakea supercluster was precisely in this process, gradually revealing its true form. But the study's greatest was not Laniakea, but another superstructure above it, the South Pole Wall. This superstructure is called the South Pole Wall because its projection in Earth's celestial sphere happens to fall above the South Pole. From computer-generated model diagrams, this arm-shaped super-galaxy cluster is embracing the Laniakea supercluster, also embracing the entire Milky Way. It spans 1.4 billion light-years, projecting a length of 500 million light-years in the South Pole region, extending along a 200-degree arc, and folding inward to within 300 million light-years of the Milky Way, ultimately merging with the Shapley supercluster in the observable universe. Even the Laniakea supercluster, with its diameter of 500 million light-years and containing 100,000 galaxies, appears somewhat small before the South Pole Wall. However, the South Pole Wall is not the largest-scale cosmic structure discovered so far. Currently ranked first is the cosmic structure known as the Sloan Great Wall. Before introducing it, we must first understand what a cosmic wall is. As is well known, galaxies in the universe form galaxy groups. Galaxy groups converge into galaxy clusters, and galaxy clusters in turn constitute superclusters. Generally, superclusters have diameters on the order of hundreds of millions of light-years, and cosmologists have found that if the view is expanded from hundreds of millions of light-years to tens of billions or hundreds of billions of light-years, what originally seemed like independent superclusters reveals a filamentary web structure. These filaments composed of galaxies are called cosmic walls. The regions filled with dark matter and dark energy between the filaments are called cosmic voids. The longest and thickest filament discovered so far is the superstructure known as the Sloan Great Wall. It is located in the depths of the universe, 1 billion light-years from Earth, with a length of 1.37 billion light-years. For an observable universe with a radius of only 46.5 billion light-years, a giant filamentary structure spanning 1.37 billion light-years is already one of the major components of the observable universe. If we also consider that the Sloan Great Wall, with its own gravity, influences the surrounding spacetime region of tens of billions of light-years, it actually governs a significant portion of the celestial systems in the observable universe. At least our Milky Way and the Laniakea supercluster are under the influence of its gravitational pull, and the future evolution of the universe will also be swayed by it. So how will the universe evolve in the future? If current estimates of the proportions of dark matter and dark energy are correct, our universe will ultimately move towards extinction in an eternal accelerated expansion. It is important to know that ordinary matter, which constitutes galaxies, stars, and humans themselves, accounts for only 4.9% of the universe's total mass. The remaining 26.5% is dark matter, which prevents galaxies from falling apart, and 68.3% is dark energy, which drives the universe's perpetual accelerated expansion, with dark energy accounting for nearly 70%. The expansion rate of spacetime will only increase faster and faster, and the scale at which the expansion force acts will gradually decrease from the current million light-year level, first tearing apart superclusters, then galaxy clusters and groups, followed by individual galaxies. In the most extreme scenario, when the universe's expansion rate reaches a critical point, all atoms in the entire universe will be pulled apart and torn to shreds by this force, including humans. All objects in the universe made of ordinary matter will cease to exist in the Big Rip. As for the aforementioned South Pole Wall, Sloan Great Wall, and the Laniakea supercluster, They will be the first cosmic structures to be torn apart by the force of cosmic expansion, because their own mass and volume are too large. The force of cosmic expansion will act on them first. In contrast, small players like the Milky Way and the Solar System will be able to exist a little longer.